Good evening. Welcome to another edition of DEBAKEY CV Live, Innovation on the Loose. Streaming live from Houston Methodist Hospital, here in the Texas Medical Center. I am Dr. Stuart Corr, Director of Innovation for the DEBAKEY Heart and Vascular Center. Tonight, we'll be learning about something very special. Working in partnership between Texas A&M and Houston Methodist, a new revolutionary course has been developed that blends together engineering with medicine. Referred to as the EnMed program, it is a dual MD master's course which employs a revolutionary curriculum blend together engineering and medicine to create the next generation of innovative physician-ears. On tonight's show, we are honoured to have Professor and Executive Dean of EnMed, Dr. Roderic Pettigrew, who will enlighten us on how EnMed was formulated and put into action. We will then have Dr. Michael Moreno, Associate Professor and Director of Innovation for EnMed, to give us an in-depth look at how EnMed is structured and what type of students they're looking for. And finally, we'll get a first-hand account of the program straight from the students themselves. And are delighted to patch in Robbie Lovin, Brianna Peacock and Austin Hughes to share with us their anecdotes and experiences so far. Before we cut to our special guests, I would like to invite the audience into our discussions. So please submit your questions via web at pollev.com using DEBAKEY as the username, or text DEBAKEY to 37607 alongside your question. You can also add your question into the live YouTube stream. So without further ado, let's crack on. And it's with great pleasure I'd like to introduce my first guest this evening, Professor Rod Pettigrew. Dr. Pettigrew, how are you doing, sir? I am not able to hear any audio in the studio, guys, just so we know.
Oh, okay.
But there we go. There we go. We're on. We're live. Always need at least one glitch. So, Dr. Pettigrew, over to yourself, sir. I'm sure we're really eager to learn more about the EnMed program and its ins and outs, and especially how it's formulated.
Okay. I'm getting a bit of an echo on my end. Is that occurring there as well?
I will defer that over to the studio. I think they're saying we're good. Are you able to just go through it?
Yes, I'm just trying to share my screen.
No problem.
Which doesn't seem to be functioning so well now. So if you actually could bring up my slides, Stuart.
I will indeed. Give me 2 seconds there. We're always prepared here. You never know what might happen. So there we go. I have your slides up in 2 seconds. Okay, can you see it?
Well, actually, I can. Unfortunately, I'm frozen, so I just sort of have to take your word for it.
Well, we're at the title page, the EnMed Concept, Innovation on the Loose.
Okay. There we are. Now, if we could go back one slide, please. And the next slide. One slide back, please, again. In the reverse direction.
We'll get there. So it's this one. That's
live TV. All right, that's a good slide. So I do want to talk to you about the EnMed concept, which is illustrated in the next slide. If you just have advanced just one slide, not more. On the slide before that one.
I'm afraid there is no slide before that. It's just the title slide, sir.
Okay. So the EnMed is based on this concept of converging engineering and medicine to create a new type of healthcare professional who has a blended understanding of both of these disciplines, which are traditionally distinct and separate. But in EnMed, we're training our students to be what I refer to as scientifically bilingual. They understand both engineering and medicine in an integrated fashion, and the goal is to use this blended understanding to better have ideas about how to solve problems and challenges in the healthcare arena. Students who are trained in this blended and convergent fashion, we call physicianeers. They are a combination, a blended combination of a physician and an engineer. But through this blending, we're creating a new type of healthcare individual who has not been purposely trained before. The goal is to create this problem-solving minded, innovation-oriented healthcare person, healthcare professional. And through that, the expectation is that these physicianeers will be able to meet and reach and surpass some of the challenges that we have. An example of that will be shown in the video to come up. And if you can get prepared to play that video, it will illustrate something that is emerging now that all of us can very well appreciate. And that is the need to have a better process for vaccinating the masses. In the current pandemic, we all need and seek vaccinations, but those vaccinations require us to physically travel to a site and physically get an injection. In the future, those vaccines could be delivered to your local pharmacy or to your home and be self-administered. And this could occur through the type of innovation that will be illustrated in the video that you can show now.
Let's go to the video number 1.
Imagine that one day you could go to your mailbox and in the mail you get a Band-Aid and essentially take this Band-Aid in the house from your doctor, place it on your arm, and you're vaccinated. Vaccinated against the flu, so you got your flu shot for the season, or vaccinated against a dreaded virus, or vaccinated against cancer. That kind of innovation occurred between the merger of immunology from the biologist and materials engineering from the engineer. These two people coming together to solve this unmet need. So in EnMed, we're going to train physicians to think like that. We will train physicians to see a medical process such as we really have difficulty in vaccinating the nation. Wouldn't it be great if everybody could vaccinate themselves? Wouldn't it be great if you could go to the drugstore and pick up your vaccine? So that sort of thinking, that sort of transformational thinking is what EnMed is all about.
Okay, Stuart. So if you could bring my slides up again, I'll close with one more example that will illustrate our aspiration in EnMed. Now, one of the biggest challenges on this planet is elevated blood pressure, known medically as hypertension. Why is it such a big challenge and a big deal? It's because if you just click, please, one click, it is the number one cause of death and disability on the planet, around the globe. It is responsible for about 10 million needless deaths per year. And one of the real challenging features is that only about half of the people actually suffer from hypertension actually know that they have it. So imagine that we had a process that could develop and monitor hypertension in a passive way that operated in the background. One more click, please. Well, that's actually a simulated animation, which is not moving. But if you can go back one slide. Yeah, I don't know why.
This one?
Yeah, so just one click.
But do one click, it goes back.
Okay, so the animation is not playing, but word playing, what you'd see is this individual walking through the doorway. And as the person walks through the doorway, it senses the blood pressure. And the blood pressure is then sent to the cell phone. And each time you go through the doorway, that happens, it goes to the cell phone. And then the next day you get up and you look in the mirror, and the mirror will show you the results that were received and accumulated in the cell phone and analyzed in the cell phone, displayed in the mirror, say in your bathroom. And all the constituent data would then be relayed to the healthcare professional. The animation is incomplete for some reason, but that is the concept, this sort of passive in the background, monitoring and detection of blood pressure without the need for a blood pressure cuff. The next slide. So we don't have anything that like that yet, but we're headed in that direction. And the bioengineer from Texas A&M, Ruzbe Jafari, is well on his way in developing such a technology. He has 2 NIH grants, as shown above. He's developing a cuffless approach to measuring blood pressure using a smartwatch. One more click, please. And the smartwatch is actually able to detect the waveform in the pulse, in the arterial pulse under the watch. And from this waveform, one more click, please, extract from that waveform the peak pressure, the systolic pressure, the minimum pressure, the diastolic pressure, and those blue graphs show the accuracy of those measurements with the measurements obtained by the smartwatch plotted against the measurements obtained by conventional methods. And the final image actually shows the inner components of the smartwatch. So we are headed in that direction with this type of technological innovation that could pay tremendous dividends in helping us to address this worldwide problem. That is the type of thing that we expect to come from the physician ears in the years to come. And I would submit even things that we can't even think of and imagine now. Those kinds of innovations are likely to come from the 3 students that we have with us today. They don't know it, but we know it, and we expect it, and we don't know exactly what they're going to do, but it's going to be something fantastic.
Well,
Thank you, Stuart.
I love how you're putting absolutely no pressure on your students at all to come up with the goods. But you're absolutely right. You know, that is a fascinating, really fantastic need, is non-invasive blood pressure monitoring, and it has not been cracked yet. But by the sounds of it, it sounds like you guys are close to it. So I think we're really nice to have a follow-up show maybe to learn more about that technology. But how did it all begin? I mean, where did the idea come from for EnMed? Was it an organic process, or was it one day, you know, just thought about it?
Well, it is the result of what one might describe as an organic evolution over the last decade to 2 decades and a half or so, where there has been this growing convergence between engineering and biology, and the appreciation that at the intersection of these two, and certainly with the integration of these two, could come greater understanding of disease. And from that greater understanding of disease, one can derive much better approaches to addressing a disease and to maintaining health. And we want to do both. We'd like to be able to maintain health, and when disease does occur, to detect it early on and to effectively treat it. The overall goal is to deliver health for all of us for as long as we live. And the expectation is that the solutions to the challenges that we have in reaching that goal would come from an approach that's most like life itself. And life itself is a seamless blending of engineering and biology.
And you know, how did you actually get this whole program off the ground as well? I mean, this is an exceptionally ambitious but very worthwhile endeavor. I just wonder, like, what was the first steps and how did you get up and running?
Well, after the concept was developed and the decision was made jointly by Texas A&M and Houston Methodist Hospital to create a formal educational research and translational program, and EnMed does have all of those components. The first component is to formally train students to be physicianeers. The second component is to have a research activity based on the integration of engineering and medicine, and that is emerging. And then the third component is to actually translate the results of this type of education in research, training, and development so that we actually are able to deliver practical products that will improve medicine and healthcare. Once that decision was made, we then proceeded to begin to recruit the faculty, both persons outside of the local area who were recruited and brought in to be instructors, but also drawing from faculty within the great richness that makes up the Texas Medical Center and Texas A&M at Bryan and College Station. So we took faculty from each of those sites, we put them into this construct called EnMed, and we looked around the country for the best and the brightest students that we could find, and we have 3 of them with us right here today.
Again, no pressure, guys. But yeah, like what an experiment. I mean, this is like where this is going is kind of, you know, it's unprecedented, and it'll be very interesting to start seeing what's coming out of this. So, you know, fantastic. I mean, but obviously with something this big, it takes a team, right? And I know, you know, one of your key team players who we also have on as one of our guests today is Dr. Mike Moreno. He is Director of Innovation for the EnMed program, and Mike is actually going to give us a little bit of information about the curriculum and what type of students he's looking for, because I'm pretty sure there's a lot of people out there right now that are frantically looking for that application to get on this program. So Dr. Moreno, I'd love to hear a little bit more from yourself, sir.
Sure, I'd be happy to do that. So, you know, as was alluded, one of the key parts of the program is this concept of blending engineering and medicine. And so, you know, how do we do that? And maybe before I even address that, you know, let's think for a second about what we're asking these students to do, since Dr. Pettigrew is raining so much praise on them. I mean, they're going after an MD and a Master of Engineering in the same 4 year.
Okay, I do believe my guests have been kicked off the internet. We are frozen. Oh no, we're back in. Okay, Mike, I think you're off there. So let's say we actually do have a video too. So let's play the video and see if we can get Dr. Moreno back in the background. Video 2, please.
The foundation upon which EnMed is built is the idea of blending engineering and medicine. This blending of the curriculum is possible in part because the Master of Engineering degree that accompanies the medical doctorate is exclusively focused on the design and implementation of medical technologies. Every student will be engaged in the development of innovative medical technologies during their time in the program. We're based in the Texas Medical Center, the largest medical center in the world. It's a hotbed of innovation in medicine. There are numerous startups and incubators here. The Johnson & Johnson J Labs are based here. Several of the hospitals have research components, including the Houston Methodist Research Institute. EnMed students have open opportunities to gain experience developing innovative medical technologies by working with EnMed researchers from Texas A&M and Houston Methodist, as well as our many collaborators in the Texas Medical Center and beyond, to include domestic and international industry, medical, and academic partners. If an EnMed student or a team of EnMed students has an idea they want to develop independently, they have great resources at their disposal. They are working with supportive, practicing physicians and experienced engineers from the time they start the program. The new building has a state-of-the-art makerspace, the EnMed Design and Innovation Center. The facility was designed with the prototyping of medical technologies in mind. It has a variety of computer-aided design and computer-aided manufacturing equipment, including 3D printers, laser cutters, and CNC. It has a fully equipped machine shop, a computer lab for computational modeling, and a tissue culture facility. There's also space and resources for electronics design, including LabVIEW and Arduino systems. The program deliverable for the Master of Engineering degree is the student's EnMed Innovation Portfolio. This is modeled after other design-oriented disciplines and will include examples of the student's work in developing innovative medical technologies. The portfolio is conceived to be more than an academic requirement. It is something the student will want to maintain throughout their career, as it can be used to pursue that top-tier residency or employment when the time comes. In addition to work completed as part of the EnMed curriculum, it may include work done prior to entering the program, as well as extracurricular activities. The EnMed student culture that has emerged since the program began is one that is very ambitious, supportive, team-oriented, and determined to collectively contribute to the transformation of healthcare for all of humanity.
Okay, so I believe Mike is, well, Dr. Moreno is also a little bit of a magician, so he's managed to completely vanish himself from the show, so we're going to work to get him back in the background. So I think we can go straight on to learning more about the students. You know, we had a big conversation yesterday, and I was delighted to learn more about the program straight from themselves. But I'd love to introduce to everyone, we have Robbie here, we have Austin, and we have Brianna. Guys, welcome to the show. Thanks for being on. So my first question for you guys is, what drew you to this program?
Well, I can go first,
yes,
if you'd like. So one reason I joined was because I didn't want to leave behind my engineering degree. So I did chemical engineering in undergrad, and one thing I love about engineering is that you can touch millions of people, but I like that personal connection with people. And the nice thing about this program is you get that experience where you can see the direct impact that you're having by innovating and touching these people's lives, but you can still impact millions of lives.
Fantastic. And Robbie, how about yourself, sir?
Yeah, so for me, something kind of similar. From the very first time I ever shadowed, you know, like within just a few hours in the operating room, I was just like, you know, this is like so incredible and so cool, but also it'd be cool if they had a tool that kind of did like this, or, you know, was shaped a little more like this, and just really like that. And then when I was applying to medical school, I found out about EnMed, and I couldn't believe that like a program like that actually existed. Just the idea that I could actually in 4 years go and get, you know, my MD, which I wanted to do, but also the whole time during like the entire 4 years be also focused on engineering innovation and what is the actual process of coming up with an idea, working through everything, validating it, and getting it to market. And the fact that there was a program literally built for what I wanted to make my entire career, like it just was perfect, and it was kind of a no-brainer for me to apply to this program.
And Austin, what about yourself?
Yeah, so from a very young age, I was very interested in entering medicine. And as I got older and entered undergrad, I became interested in engineering. I would eventually work with companies such as Abbott in developing LVADs, but then I would also go and do internships with, say, for instance, the Texas Heart Institute, working on similar devices. And along the way, I was able to learn that I could apply that scientific knowledge towards creating new devices. And in that entire process, I would be touching the lives of, in the end, say, millions of people. And EnMed really offers that ability to touch lives not only through medicine, but through innovation and design. And both those combined is really what I was looking for growing up, and that's where I am now.
Superb. So you're literally in the heart of some of the heart labs over at the Texas Heart Institute, you know, working like Billy Cohen, and then it sounds like you just fell in love with innovation engineering and ended up at EnMed. So it's fantastic, you know. And You know, talking about the engineering skills that you guys learn, I mean, obviously there can be a lot of theoretical background and fundamental principles that they can take a lot of time to learn. You could spend a whole 4 or 5 years just on theory, but it seems that the engineering skills you learn in this program are more tangible. You know, like you can apply something directly to building something very, very quickly. So, you know, maybe enlighten me on that. You know, what kind of engineering skills are you guys learning, and what systems and stuff like that?
Yeah, so I mean, it was one of the biggest questions on interview day that pretty much everyone had, because to be in the program, you had to have something kind of like an engineering background or something similar to that. And so all the mechanical engineers, you know, like myself, are asking like, how much coding do I need to know? And all the electrical engineers are like, do I need to know, you know, how to machine something? You know, do I need to know mechanics really well and things like that? And everyone's really nervous about, are those the types of things that we're going to learn about in this program when we're getting that master's? And, you know, Dr. Moreno was there on our interview day, and he says, that's not really what we're going to focus on. You're coming into this knowing all of the hard skills, essentially, like the real science of engineering. You know, we're trusting that you learn that in your undergrad degree. What we're going to focus on is actually translating your engineering knowledge in a practical way and being able to actually make devices and actually like taking that next step for, okay, you have an idea, but here's how you actually move forward with that idea, get it to market, understand that you're, you know, creating like a valid need and filling that. So it's a lot more practical engineering and less of the hard skills, if that makes sense.
Completely, yeah. And Brianna, you know, you were saying there that your background is in chemical engineering, so I'd be interested, you know, how did you find learning things like Arduino and AutoCAD, etc.? How did you take to that?
You know, it was very foreign to me, and we just did a few workshops on it. But, you know, I think they were very clear when they would give us lectures, and then we would do a workshop, and we would do it in groups. So if one of our team members had experience, we could learn from somebody who, you know, maybe they weren't an expert, but they knew pretty well what they were doing. And so, you know, even if I am not personally an expert in one of these hard skills, I have a better understanding of what goes into them. And if I'm working with a partner who has experience and we're using, you know, Arduinos, for instance, then I know what's going on and I can communicate with them.
Absolutely. I mean, you know, innovation, a huge part of it is teamwork, right? So you identify your strengths and weaknesses, etc., and, you know, complement and synergize with each other. Now, you guys were saying yesterday that, you know, you're initiated with the biodesign program from the very beginning, which is, you know, it's almost like the bread and butter for innovating in med devices and med tech. You know, very, very strong. But, you know, after that, what is your process for generating ideas and pitching those ideas to the correct people? So maybe Austin, you can go first.
I think this is really one of the most unique aspects of EnMed. And to explain this, I'm going to actually explain a little bit of what goes on during our first semester of medical school. So we have this practice of medicine class where we will learn parts of the physical exam, and then we will have a clinical reasoning session after where we will walk through the entire process of diagnosing a patient and treating a patient. So say, for instance, we have a patient with coronary artery disease. We'll be walking through that entire case. And in that process, we'll be interacting with clinicians and be able to identify problems that came up in that care or anywhere where improvements could be made. And that was really the beginning of the stepping stone of beginning to find and identify clinical needs, and then start that process of translating it into a product that can become something very impactful in the world. And so we would take these ideas, go through this process of learning more about the disease state, completing stakeholder analyses, and many other processes. And then that would ultimately allow us to generate a solution. And we would pitch this back to that same clinician or other clinicians within the Houston Methodist system or those outside of Houston Methodist. And that would really allow us to take this idea into a reality.
Fantastic. And Robbie, would you like to comment on that further?
I was just going to say, I just love the whole process, like Austin was saying, in that first class that we had, or not the first class, but when we just got to keep seeing, it was like week after week, you know, getting to learn how to do a, you know, physical for a certain system, actually hear a case about it, and then actually develop this idea, and then get to actually pitch it back to the same, you know, clinician who had presented this idea and get feedback, not only from that, you know, clinician, but also there'd usually be an engineering professor in that meeting. And so it'd be us pitching it back. And they'd, sometimes it'd go great and they're like, this is an amazing thing. This is amazing. I can't believe this doesn't exist. You should really work on this right now. And then other times they're like, here's some thoughts. It was always great. It was always great because, it's a learning process. And it was so much fun because in that first semester, we're doing it so much. It was such a fast process, and it was just like, we'd have to just week after week, like identify a need, pitch an idea, get feedback on it, learn and grow, and just over and over again. They're just really inundating us with that bio-design process. And I loved it.
So on that note, I'd love to know, what was the worst idea that you've pitched so far?
So yeah, we talked about this one. Yes, I had a good one. I stand by. I think it's a cool need. So one of the things that I love that this program really taught me is don't have a solution in mind and then force something to fit that solution. So you start with identifying the problem. And after we had our pulmonary case, I found out about pulmonary lobectomies and doing them through minimally invasive methods. And so it's removing a portion of the lung, and they can do the entire procedure with just these tiny, little incisions that are going to have, one or two stitches to close up at the end. The problem is, at the very end of the procedure, you have to actually get that tissue that you've excised out. And so then you have a problem because you only have these tiny holes. And so what happens is at the very end of this surgery, you have to make, a large incision and get that out. So I thought that was a really cool problem, and I wanted to try to solve it. So I racked my brain and then ended up coming up with this idea of basically, what if you could essentially minimize the size of that tissue through this creative process I diagrammed out for them, bagging up the tissue and blending it up in this bag and then removing all of that. The problem with it was, and where I got some great feedback was two things. One, a lot of the times of doing that is cancerous cells. And if you're doing that, could you potentially be spraying something like that all over the chest cavity? And I was like, that's a very good point. That's a very good point. And they were also like, every pathologist in the hospital is going to hate you because they love to get their little pathology samples, and you just turned it into, the term that I used in my presentation was mush. And they're like, yeah, they're not going to like that at all. I was like, those are very good notes. But I was talking to these two clinicians and one of our engineering professors, and they were like, listen, here's the feedback on the idea. Like, that's something you need to work on, but also this is a really great need state. This is a real problem, and this is something worth pursuing. But these are some of the things you need to consider in the next iteration. And that was a lot of fun. I really liked pitching that one because I really believed in the idea a lot. It was a lot of fun having them point out, where there was still some room for growth. And that was probably the biggest learning experience for me, of the most hesitancy from a clinician after hearing my idea.
Well, I'm glad you went through that experience. Sometimes the hard part of innovation, right, is you get feedback from the surgeon clinician and they think it's a terrible idea. But then, lo and behold, it's actually an amazing idea, So it's all about just perseverance, right? And being able to work out, I think, just like separating a good idea from a bad idea, etc. And we have Dr. Moreno back online here, and before we patch over to him, I'd like to ask your students, what are your biggest needs at the moment? Is there something that extra that you'd like to get that maybe isn't happening at the moment, And Austin.
Oh, yeah, Austin, you go ahead, man.
So one of the greatest needs that I think, and this would greatly affect our entire class and the incoming classes, is that me personally, I came into this program with a little bit of engineering experience, a little bit of clinical experience, and was actually able to integrate that at a very early point in my career. And so one of the greatest needs I think right now is, say for instance, creating maybe a small internship or something at the very beginning of the EnMed curriculum, where you put a student with an engineering company, say for 2-3 weeks, and let them go through that bio-design process or parts of it, and also allow it to integrate it with the clinical aspects so they get both parts of it. Because in the end, after I went through that this past summer, I was able to have a more complex understanding of how the bio-design process works, but also how I can become a better clinician in the process, and how I can generate a bit greater impact for my patients.
Superb. And Brianna?
You know, one thing that I love that our program does is they bring in companies like Procerian, which is a cardiology biotech company, and other companies, and they have them give us lectures essentially on, you know, what they do and what their goals are, and we get to talk to them firsthand and learn about the biodesign process from people who have been there. And I think one really neat thing to do would be to maybe have some workshops with them, and they can teach us some of their skills and, you know, different things that they do to develop the technology that they do.
That's excellent. And Robbie, what about yourself?
Yeah, and so one of the things that I want to see us keep working on, this is something that's going, it's been underway right now, actually. I know some people are working on it, and that's helping us get a little more connected with the faculty over at Methodist and just clinicians in general. Just because, like I said, when I was pitching that idea, it was great to get to hear back from those clinicians on their opinions about the idea. And we are connected very well with a lot of clinicians at Methodist, but it's always nice just having these or official channels for us to go through. But this is something that's, you know, set up very well. And one of the fun things about EnMed is, you know, we're taught identify a need first and then create a solution. And so because of that, us as students, we're very, you know, the faculty is so incredibly receptive. This program is so young. And so all the time we're coming up with these different ideas of, you know, the program could work a little better, but we got to do this instead. And we're always, you know, being encouraged to just identify all these different areas the program can improve. And that's one thing I love about it. And so even just a few weeks ago, I was saying it'd be nice if we could try to get a little more connected with faculty at Methodist. And already in the span of just a few weeks, they're putting together, you know, sheets for us of here's all these people in all these different departments. And that's something that is, you know, coming to fruition in the span of weeks. That, you know, we express an interest in it and they're making it happen. But that's something I'm very excited to see move into the future and allow us just to connect even more with all those clinicians so that we can flush out these needs, get more involved, things like that. Something I'm very excited about for the future of this program.
It's fantastic, and I think we actually even came up with a couple of ideas ourselves, right? Yesterday, guys, you know, let's look at building an app or something to kind of like enhance that. You know, it's, again, we're just innovating, right? We just can't stop, you know. Well, I do thank you for your insights there. You know, again, and good luck to you for the next few years. I can't believe we only just started this kind of last year. Before we patch back to Dr Moreno, we do have a little video clip of a kind of day in the life of some other EnMed students as part of the program. So can we just run that video, please?
Thank you, Dr. Moreno. I'm Zach Richards, current EnMed student and class officer. It's an honor to host you on a tour of the outstanding opportunities that await you in the EnMed program. Along with a couple of my fellow classmates, I hope to provide you with information that will be as fun and informative as an in-person walk through our program. Like many aspiring physicians, my goal in medicine is to enrich my future patients' health and well-being, but my dream goes so much further than just providing established standards of care. I have discovered a personal passion for medical innovation, and I needed a program that cultivates that passion into real benefits for patients. EnMed is that program. The student experience goes so much further than the classroom. I'm not just learning about the biodesign process, but I'm actually working through it with projects that I get to choose. Whether it's developing software to streamline N95 fitting during the COVID-19 pandemic, designing an open source ventilator for low resource areas, or rethinking the way we approach visual field testing, one thing is for sure, I am an innovator now.
You have to learn the science of medicine to be a good doctor, but effecting change in the medical field takes something more. I studied biomedical engineering at Johns Hopkins and prepared to build the technology that could treat conditions in ways once thought impossible. I then earned my MBA to discover how to commercialize, market, and manage those innovations in order to reach more patients. Ultimately, I realized that the impact of any startup I launched or any hospital operation I improved depended on the doctors themselves. To drive real change in medicine, I needed my white coat. Texas A&M's EnMed is founded on interdisciplinary principles that can drive sustainable innovation in healthcare. The chance to join the largest medical center in the world, practice at the #1 hospital for patient care in Texas, and share ideas with Texas A&M's unmatched alumni network was an opportunity I just couldn't pass up. My future goals surpass practicing medicine as it's taught. I want to change the way medicine is practiced to fit the changing needs of our patient population. Medicine is dynamic, and our physicians should be too.
Doctors are smart people. If you ask pretty much any doctor if they have any good ideas for new devices or procedures, they're likely to flip over a napkin and draw out a schematic for something that could potentially help patients around the world. What makes EnMed special is that it gives the doctors of the future the ability to make those napkin drawings become reality. EnMed is unique in its deliberate curriculum design to put the tools necessary to innovation into students' hands, including validating clinical needs by collaborating with experts at Houston Methodist Hospital, creating prototypes in our makerspace, and learning how to navigate regulatory and market pathways in order to make your bright idea a reality. As someone who is extremely passionate about increasing access to healthcare for underserved populations, I know that the creation of innovative medical technology will only grow in its role as a way to steward the wellness of our communities. With that in mind, I chose EnMed because I believe that the unique curriculum will prepare me to not only be an effective doctor, but also a purposeful innovator.
Although we wish we could provide you with an in-person tour experience, we hope that this brief video provided a glimpse inside our program and of the outstanding training and research opportunities that await you at Texas A&M and Houston Methodist. Stay well, and we hope to see you at EnMed in the future.
5, 4.
Okay, excellent. So, Dr. Moreno, we have you back online, and just so you know, we have played the movie clip or the video clip of yourself giving a highlight of the curriculum. But I'd love to know a little bit more about the curriculum, especially the blended activities between medicine and engineering.
Sure. And I'm not sure what happened before, but I'm going to try and dive in with the same enthusiasm I started with. So, again, these students are trying to get an MD and a Master of Engineering degree in 4 years. There are actually three important ways, that we're trying to make that happen. So one is blending the curriculum. And as I was going to say, there are two kind of primary approaches that we take toward that. So one, I call it concurrent blending. So if they're learning about, respiratory physiology, as I was starting to mention before, at the same time, they might be learning about different technologies that are used or being designed to diagnose, treat, monitor patients that have respiratory ailments. Now, these could include device-based therapies or image-based therapies, gene therapies, pharmaceuticals, really any kind of medical technology that would be used in that realm. Then they're going to learn something about that. And the other way, and for a lot of people, this is, perhaps the more interesting approach, is that we view the human body as an engineered system. And so when they're learning about the structure and function of cells, tissues, and organs, we might use engineering terminology to describe that. And in the cases where we've done that, because this is something that we're developing as we're going through this curriculum, and the engineering faculty and the medical faculty are working together, we're getting very positive feedback from the students. To remember, that's their background. For most of them, it's engineering. It could be computer science, but this starts to resonate with them. And as I was thinking about this and how the faculty are working together, one of the things that occurred to me is, the program is producing these unique physicianeers, but the other thing that's happening is the faculty are becoming unique because they're being hybridized themselves and learning, the engineering faculty are learning so much more about, what it means to kind of train a medical student and vice versa. The medical faculty are starting to learn what it means to train a student in engineering innovation, engineering design and innovation. And so that's another kind of peripheral benefit that I've found very interesting lately. Now, the second thing that's really important is that, the Master of Engineering degree here was designed for this program. And so whether or not the students have a background in, we heard some of these students talk about, mechanical engineering, electrical engineering, it could be computer science, physics, or some related discipline, they're all pursuing the same Master of Engineering degree. And this is focused on the design and innovation, development of medical technologies from concept into clinical practice. And so that's another important part. And I think the reason why that really contributes to being able to do this in 4 years is, what I described earlier, as they're talking about respiratory physiology, the engineering training that they're getting, can still be talking about the same subject matter. And so, this is, again, part of this blending of the curriculum. The Master of Engineering degree being kind of focused on that topic, I think, is really important. Now, one of the things I want to expand on here after listening to the students talk, which was really nice to do, by the way, is that, one of the tactics that we take that they kind of alluded to is really from the moment that they're in the program, we've got them practicing what they're learning. And so this is really an important concept because, as a musician, I could show somebody where to put their fingers on a guitar, but unless they practice, they're not going to get good at it. And another example I give is basketball. Pretty simple concept, put the ball through the hoop. But if you don't practice, you don't get good at it. And so it's the same thing here. We can teach them, the idea of identifying and defining a problem well, but I think they would all agree that the practicing of this and having them go through this, they've kind of alluded to that, has been what's been really helpful for them. They're going to get better and better at this. And now keep in mind, here's what's happening is the inaugural class, right? So this is the class that are ahead of the students that we're seeing here. They just started their clerkships. And one of the things that we have them do while they're in the clerkships is they're journaling and they're identifying different opportunities to innovate. And this has been really, really interesting. We've worked with the Methodist clerkship directors and kind of developing, what should be the content of these journals. I wanted to make sure that I figured that each clerkship might be unique, right? So I elucidated kind of the ideas that they were giving me in terms of what we might expect. And we laid out some different options for the students. And as we started seeing these journal entries, it was amazing. I think one of the things that the students learned from that is some of them, had talked to me earlier, how am I going to identify a problem that I can work on? And they were concerned about that. And I think most of them would now say that, I'm in my clerkships, I'm seeing all kinds of things I could potentially work on. It's no longer, is there going to be an opportunity for me to improve healthcare? It's going to be, which of the opportunities do I want to take advantage of? Where does my passion lie? And what do I want to work on? Now, the other key part of this, and this is something that the inaugural class did not benefit from, is that, the observations that they're making that maybe they decide, this is a real need, but my interest is over here. So I'm going to wait till I hit this clerkship because I can see now that I'm probably going to find some things, some opportunities for myself. Well, we're taking those opportunities that they've identified, and we're actually going to incorporate those into the pre-clerkship program. So when they're talking about, the POMs and the TBLs that they're going on, the students I'm talking about now that we're seeing that are participating with us, they've been identifying their own problems, but imagine, I'm going to ask the students now, kind of imagine that the next year when they're coming in, they're actually going to be given these real world observations that have been made by the students ahead of them. And when you're in your clerkships, you're going to be doing the same thing, making these types of observations and bringing those in and feeding those into the curriculum so that even in the pre-clerkship training, there's going to be very real world problems that people are going to be addressing. The other thing that's important is the student culture that's emerged. And so I did a presentation early on with the inaugural class, and I said, you guys are the first ones, you're the trailblazers. There is no culture of EnMed. You guys are going to create that culture. And it's been amazing to see the culture that they've created, including working with the class that's kind of coming in. They communicate with each other really well, and whenever I talk to them, they seem to get along really well. I think that there's a mutual appreciation that they have this kind of shared interest in becoming a physicianeer. I'm seeing some teams kind of organically form. And so whenever we talk about, again, vertical integration of the program, so now imagine, a year from now, and then a year from now, we've got 4 years of students going, and these vertically integrated teams of varying levels of experience, kind of mutual interest, because they'll be working with students that might be in a clerkship that is in their particular interest. And being able to get feedback from that student of what it's like to be in that clerkship, what are the kinds of observations you're making. So I think this is going to be a really important part of the program. And so that'll bring me to my third point that I think is has nothing to do with the curriculum. And this has everything to do with the students. And so, I think one of the students talked about the interviews. One of the things that we're really looking for, and by the way, we get really good candidates. I mean, these students are excellent, as Dr. Pettigrew said. All the candidates have good GPAs, like great GPAs, great scores on the MCAS, but we're looking for, in addition to that, this personality type. These students that have a passion for creating things, for designing things, for tinkering with things. This is really important to trying to do this in 4 years because that type of student, that type of mindset is not going to see the engineering as kind of this additional burden that's been put on the medical curriculum. In fact, when they want to decompress from, having that medical, examination or, studying for something, the way they're going to decompress is thinking about, man, I need a solution to this problem. Now's my opportunity to start thinking about that. This is something that they have a natural passion for. Now, Stuart, if I can I share my slides, or do you want to put my slides up? I know
we're actually almost out of time there. There might, we've got to have a little bit of time for our discussion. But
sure.
we can make those available offline to anyone that needs to get access to them. We can provide all that information. And I had a bunch of questions here for you, but you've actually answered them all. So as we're kind of closing for the evening, I guess I want to open up for question answers, and we've got a great question that's come in. Now, is how do you see EnMed changing over the next 10 years? So maybe we can roll this into Dr. Pettigrew.
Sure.
Well, that is indeed a very good question. And the truth is that we are continuously striving to be the leaders in innovation on this planet in the medical space. And because innovation is limitless, that it's based on not only training and having the tools and the acquisition of those tools, as Kaylin said in her video segment, but it's also based on imagination. And we know that there is no limit to imagination. There's no limit to creativity. And therefore, there's no limit to innovation. So it's difficult to predict exactly where things will be in 10 years from now. But what we can say is that we are continuously striving to be at the point of the tip of the spear that is piercing the challenges ahead of us through technological innovation born of a convergence of engineering and medicine.
Well, I think that is an excellent way to end our show for this evening. It's innovation, right? It's the game that never ends. Yes, Dr. Pettigrew.
Stuart?
Yeah.
If we have a couple of minutes, I may have solved the challenges that we had before. And I do want to show that slide that had an animation on it that we just couldn't quite get to animate. So do we have 2 minutes?
We have 2 minutes, yes. We can't get that slide though, it's still not working, unfortunately. But by all means, 2 minutes, floor's yours.
Okay, let me see if screen share works. And if it does, I'm good to go. And if it doesn't, I'll pitch it back to you, and you can end it. But do you see my screen now?
Yes.
Okay, so we were talking about meeting this global challenge we have of not being able to do a good job of detecting blood pressure because it requires an active process. The idea here is to innovate in a passive process. The person walks through the door, the blood pressure is sensed simply by walking through the door, something that happens all the time. That information is sent to your cell phone, it's accumulated, and then the next day you walk in front of a mirror. That morning you get up and you go in your bathroom and you look in the mirror, and the mirror shows you the average blood pressure that you had based on the cumulative data that was acquired. And all of that cumulative data is sent to the referring physician. So the physician has the details, the patient has the sum of the details, and has an advisory on whether to modulate your blood pressure medicine, seek medical care, or whether or not you're good to go. That is the kind of innovation that I would like to see come from this program. It hasn't happened yet. It is an aspiration and something that we can work towards. This kind of problem solving and problem solving like this is what we expect to happen consequent to EnMed and its physicianeers.
seen that happen. I'm sure it will at some point, and it's got to come through EnMed. You know, I think we also need a little challenge board of the fastest time it takes from concept to FDA approval. Okay, and we just make it right there so everyone can see it. I think that would be really interesting. But let's say, you know, thank you very much for coming on the show there. And again, I do wish you all the best for the program. We've got a lot of projects in the Heart and Vascular Centre and the DEBAKEY Department of Cardiovascular Surgery. So let's see what we can do in that area. And just to finish off the evening, a couple of special events that are coming up. I'm going to share just 2 to 3 slides. If we could just patch to them. Okay, so happy Earth Day, everybody. Today is Earth Day 2021, but it's also coinciding with Greentown Labs Houston opening officially today, Midtown, right next door to their new neighbours, Ion Houston. So we're really excited, you know, to see innovation come out of there. And regarding our pumps and pipes, we have a brand new mini-series now. It's called History in the Making. So these are short kind of animated clips talking about, you know, very, very innovative and pioneering aspects of history. For example, we have John Logie Baird. He was the Scottish inventor who invented the television. We all take TV for granted. We're looking at it right now. But do you actually know who invented that? How did that come about? What was innovation there? So that's the story that we're trying to tell in Pumps and Pipes. Next, we've got 2 events coming up, again with Pumps and Pipes. Dog Noses in Medicine. We have dogs that are sniffing out cancer and COVID. And you will hear all about it next Monday at our special Lunch and Learn series. We're also taking part of a brand new thing called Houston Tech Rodeo. This thing is absolutely fantastic, and we're very honoured and proud to be part of it. We're calling it Inner Space, Outer Space, and Earth Between. And we're going to be talking about some very interesting, innovative developments in 3D printable lungs. There's some aerospace stuff in there from Axion Space. And basically a bunch of really very interesting energy kind of going on. But just tune in, you really won't be disappointed. And finally, you know, we've all heard of Brexit, right? We've all heard what happened there a couple of years ago. And, you know, there's a lot of very interesting technology coming out of the United Kingdom at the moment. I mean, very, very, very innovative, very interesting. So we decided, right, let's put an event on and get all those people in the same room. So we're calling it Hybrid Health, and it's enhancing the UK-Texas Healthcare Exchange, and that's coming up via Hopin on May the 26th, 9 to 1:30. So if you're interested in getting your hands on some very interesting new tech from the UK and learn about academic cross-exchange, and maybe there's even a potential to bring in some UK students into the EnMed program. That's what I'm thinking about this, guys. So on that note, I'd like to just thank you everyone again, and we are done for the evening. See you next time.